All right, Aspen, we are starting chapter 9 now, and we're going to shift gears to fractions. And really, these next several lessons, I'm only going to make you one video because it's stuff that we've already learned and have done in daily math all throughout the year. So it shouldn't take a whole lot of explanation. We're going to start, the first few assignments will just be about adding fractions, but it's going to be fractions with unlike denominators. And as we've learned, even back in fourth grade, in order to add or subtract fractions, they have to have the same denominator. So, sorry, let me get to the right pages here. We're going to actually skip a few lessons. We're not going to do all of the lessons in chapter 9. But just to give you a quick rundown of what we're doing over the course of the next several days. So let's say I have 1/2 plus 3/10. Okay. Now you should recognize first, you got to check your denominators. Are they the same? Okay. Obviously they're not. So then you ask yourself, can my little one turn into the big one? And in this case, a 2 can make a 10. So I only have to worry about changing this fraction. And in order to turn a 2 into 10 using multiplication, I'm going to multiply the top and bottom by 5. So that becomes 5 times 1 is 5, and 5 times 2 is 10. Then I just use this one, and then we get 8/10. Okay, so this answer is correct. However, if possible, we are trying to do what's called simplifying fractions, getting them as low as we can go. And this is thinking about if numbers can still be divided to get smaller. So in this case, 8 and 10 can both be divided by 2, because whatever I do to the top, I do to the bottom. So an equivalent fraction of 8/10, if I divide by 2, would be 4/5. Divide 8 by 2 to get 4. 10 divided by 2 is 5. Now this is simplified because other than 1, there is no number that can divide both a 4 and a 5, because 5 is prime. The only way to make 5 is with 1 and 5. So we are practicing doing the simplifying, but technically 8/10 is correct. It's not a wrong answer. So a few more examples. Let's say I have 2/3 plus 5/9. Check your denominators. They're the same. So ask if the little one can turn into the bigger one, which it can if I multiply by 3. You got to do top and bottom. So new equivalent fraction then is 6/9 plus the original 5/9 over here equals 11/9, which you might remember this is called an improper fraction because my numerator is bigger than the denominator. So while this is a correct answer, we could say that this would equal 1 whole, because it would take 9/9 to make a whole. If I take 9/9 away, that leaves 2 left, like a remainder. So you'd have 2/9 left over. But you shouldn't have too many of those. We were getting some problems then. Let's say I had 3/4 plus 2/6. Okay. So denominators are not the same. However, I cannot turn a 4 into a 6. So you want to think of a number they can both make. And whenever possible, this is important, whenever possible, try and think of the smallest number that they can both make. So for example, 4 and 6 can both make 24. They can. And what you get from that would be a right answer. But there is a smaller number that both 4 and 6 make. So for example, 4 can make 4, 8, 12, 16, so on and so on. 6 can make 6, 12, 18. If I kept going, I would get 24. Kept going on this one, 20, 24. So like they do both make 24. But look, they also both make 12. And that's smaller than 24. So whenever possible, try and get the smallest number they can both make. So let's go with the 12s. In order to turn this side into 12ths, I would have to multiply by 3 for top and bottom. In order to turn this side into 12ths, I would have to multiply by 2, top and bottom. So my new problem then would be 9/12 plus 4/12 equals, oh, we're going to get another improper, 13/12, which would equal 1 and 1/12. You're not going to get a bunch of these impropers, I promise. My examples are not proving to be very good. Let's do, let's see, let's do 1/10 plus 2/4. So this is another one. Okay, they're not the same denominators, but I cannot turn a 4 into a 10. So I want to try and think of a number they both can become, but I want to find the smallest one. So yes, it's true they can both make 40, because I could do 10 times 4 or 4 times 10. But if I think about my multiples, 10, 20, 30, 40, and then I think about my multiples of 4, you should recognize that they can both make 20. So on this side, if I multiply by 2, this side I would have to multiply by 5. Okay, so I would get 2/20 plus 10/20 equals 12/20. Okay, so you have to do the same process even if we were subtracting. So let's say I had 4/6 minus 1/3. You have to have the same denominators. So I can turn the 3 into a 6, so I only have to worry about doing this side. So I'd have to multiply by 2, top and bottom. So it would actually be 4/6 minus 2/6, which would be 2/6. And then if you were going to try and simplify, I mean, this answer is correct, but if you were going to try and simplify, see if there's a number that can divide both the top and bottom. And in this case, they can both be divided by 2, which would then give us 1/3. So 2/6 and 1/3 are equivalent. They're both right in their answers. So hopefully that quick review kind of makes sense as you work this week to add and subtract fractions. Obviously, just have your mom get in touch with me if you're feeling confused about things. But like I said, we've been doing this on our daily math quite a bit this year, and we've learned it last year too. So hopefully it'll just be a bit of a review. All right. Thanks, Aspen.